today's lesson is on the distance formula. As usual, we have a video guide to go along with this video. If you haven't printed it off already, go ahead and pause the video, print the video guide, and then come back and you can work out these problems with me. So we're going to be finding the distance between 2 points on a graph. Alright, to do that we are going to be using the distance formula. Now this is one of the formulas that you are given on the reference sheet for the math section of the test. So you don't have to have it memorized, but you do need to know how to use it. So we're going to go ahead and go over that today. So here's our equation, our formula that we're going to be using. D, which stands for the distance, equals the square root of, and then in parentheses we have x2 minus x1, and that quantity is raised to the second power. And we're adding to that y2 minus y1, again in parentheses, and that's being raised to the second power as well. Now, you should notice the x2, x1, y2, y1, we have seen those before. We used these in the slope formula when we were trying to find the slope between 2 points. Okay, we saw x2 and x1, so that concept should be familiar to you. We're going to go ahead and go over it one more time, just to make sure you know where to get those numbers from. So we will be given 2 points. Remember, x always comes before y in an ordered pair. So in our first point, the first point that you see in your problem, x is going to be the x1. The x coordinate for the first point is our x1. The y coordinate for our first point is the y1. The second point that you come to, the x coordinate will be x2 because it's the x coordinate of the second point. The y coordinate will be y2 because it's the y coordinate of the second point. Okay, so that's how you're going to know what numbers to plug in here. And then of course D is the distance, so that's what we're going to try to find today. So let's take a look at problem number 1. We are given a graph for this worksheet. So the 2 points are given to us on the graph, but we don't know the coordinates of those points. So we're going to go ahead and find those out. Now again, x comes before y. Remember, the x-axis is the horizontal axis, the y-axis is the vertical axis. So let's start with this point. This will be our point number 1. All right, the x-coordinate, we start at the center and we go to the left 1, 2, 3, 4, 5 places. So our x-coordinate is -5. Remember, left means negative, right is positive. Now for this point, we actually have no movement up or down for the y-coordinate. So that means the y-coordinate is going to be 0. We don't go up, we don't go down, we stay right on the axis. That means the y-coordinate is 0. So our first point is -5, 0. For our second point, I'll put 2 here so we know that's the second point. Start at the center, we would have to go to the left 1 place. If I go any further, we've gone past our point. So left 1 place, that means -1. And we would go down 1, 2, 3, 4, 5 places. Down is also a negative amount, so that would be -5 for our y-coordinate. So we have our x1 here and our y1. This is our second point, so that's our x2 and y2. Now that we have the coordinates, we can plug it into the distance formula. So we're going to have D equals the square root of, and then in parentheses, x2 minus x1. Well, my x2 is -1, and we're subtracting from that x1, which is -5. We're going to have to square that. After we've done what's inside the parentheses, we will take it to the second power, so don't forget that exponent. Next, we have an addition sign in our formula, so we'll put plus, parentheses again, y2, our y2 is -5. So I'll plug that into my parentheses, and we're subtracting from that y1, which is 0. Again, end the parentheses and raise it to the second power. Now, we have subtracting with integers, okay? So we're subtracting a negative amount. So I'm going to go ahead and change that. So I'm going to have D equals the square root of, we have -1, but instead of minus -5, I'm going to change that to plus +5. Still squaring it. Adding to that, -5 minus 0 squared. Now I'm going to start actually solving the problem. So D, our distance, equals the square root of negative 1 plus positive 5. If the signs are different, remember we will subtract. So 5 minus 1 is 4, and we're raising that to the second power. Then I'm going to add to that negative 5 minus 0. Well, if we're taking away 0 from it, that means it's not changing at all. So negative 5 minus 0 is just negative 5. And again, we're still squaring that. So once we've done what's inside the parentheses, now we're going to do the exponents. You should notice that we are following the order of operations while we are solving this formula, okay? Order of operations still applies. So let's go ahead and do the exponents now. We have our square root still, 4 squared, or 4 to the second power. That means 4 times 4. So 4 times 4 is 16. And then we add to that negative 5 squared. That means negative 5 times negative 5. 5 times 5 is 25, and a negative times a negative is a positive. So we'll go ahead and put positive 25. Next, we need to add those two amounts together. So 16 plus 25, you should get 41. Now here you're going to want to use a calculator, okay? So the square root of 41 is not a nice round number. So go ahead and plug that into your calculator. If you have one of the calculators for the test, you're going to hit the second button first, and then you're going to hit the x to the second. That will give you the square root symbol, and then you type in the 41. All right, and then hit enter. You should get 6.40 if you round to the hundredths place, and that's what we're going to be doing today. We're rounding to the hundredths place, so 2 decimal places. So 6.40, that's the distance between these 2 points. Okay, so that many units to get from negative 5, 0 to negative 1, negative 5. Okay, so that's how we use the distance formula. Let's go ahead and try that again, but with problem number 2. So again, we are given 2 points on the graph. There's a line in between. I don't know the coordinates though, so that's the first thing we need to do is figure out the coordinates for each point. Looking at our first point, so that's point number 1. We start at the center, we go to the left 2 places, so that's negative 2, and we go up 1 place, so that's positive 1. So negative 2, 1 is our coordinates for the first point. So that's our x1 and our y1. So our coordinates for the second point, number 2, start at the center. We would go to the right this time. Right is the positive direction. So we're going to have positive 2, and then we count up. 1, 2, 3, 4 places. Up is also positive. So that's positive 2, positive 4 for our coordinates. And that's our x2, y2. Now we can use those coordinates, plug it into our distance formula. So we have d equals the square root of, and then let's plug that in. So we need to do x2 minus x1. x2 is 2, so we're going to have 2 minus x1 is negative 2, and we're raising that to the second power. We have an addition sign in our formula, so that comes next, parentheses again. y2 minus y1, so we're going to do 4 minus 1. And we're raising that to the second power as well. Now, we have subtract a negative here. Alright, so I'm going to go ahead and change that to adding the opposite. So it's going to become plus a positive. Remember those rules of integers. So let's go ahead and calculate that. We have d equals the square root of 2 plus positive 2 is 4. We're raising that to the second power. And then we add to that, our next set of parentheses, 4 minus 1 is 3 to the second power. So now we can do our exponents. We have d equals the square root of 4 to the second power is just 4 times 4, so that's 16. And then we add to that 3 to the second power, which is 3 times 3, so that's 9. So we have d equals the square root of 16 plus 9 is 25. This one we actually don't need a calculator for. The square root of 25, we should know. What number multiplies by itself to give us 25? The answer is 5. So the distance between these 2 points actually comes out to be a nice whole number of 5. So the distance for number 2 is 5 units. For problem number 3, we have our graph. We need to figure out the coordinates for our 2 points. So I usually start with the one on the left. We'll make that point number 1. So to find the coordinates, we're going to start at the center. We have to go left 1, 2, 3, 4 places. Remember, left is negative, so that would be a negative 4. And then we have to count down 1, 2 places. Down is also negative, so that would be negative 2 for our y coordinate. So our x1 would be negative 4. Our y1 is negative 2. For our second point, we're up here. Call it point number 2. To find the coordinates, we start at the center. We would have to go to the right 1, 2, 3, 4, 5 places. So that would be positive 5 because right is positive. And then we would have to count up 1, 2, 3, 4 places. So that's positive 4. So our x2 is positive 5. Our y2 is positive 4. Now that we've found the coordinates, we can go ahead and plug the information into our distance formula. So we're going to have d equals the square root of, in parentheses, we want x2 minus x1. So x2 is 5 minus x1, which is negative 4. And we will need to raise that to the second power. We have an addition sign, so we need that. After the addition sign, we have parentheses, and then y2 minus y1. Our y2 is positive 4 minus our y1 is negative 2. And we're raising that to the second power as well. Now remember, when we have subtracting a negative, we need to change that to adding a positive. Same thing over here. We have 4 minus negative 2. That becomes 4 plus positive 2. So now we can go ahead and work this out. We have d equals, start with the parentheses. 5 plus positive 4 is 9. So we have 9 to the second power. And we're adding to that, 4 plus positive 2 is 6 to the second power. So we have d equals the square root of 9 squared, just means 9 times 9, so that's 81. And we're adding to that 6 squared, which is 6 times 6, that's 36. So our next step, we need to go ahead and add those together. So we have 81 plus 36, which is 117. And then the last step is to go ahead and take the square root of 117. This does not come out nice and even, so you do need to use your calculator. Remember to plug that in. You'll hit second, then the x to the second button, then 117, then hit enter. Rounding it to the nearest hundredth, that's 2 decimal places, you should get 10.82. So that's the distance between these 2 points. For problem number 4, we have the 2 points on our graph. So the first thing we need to do is figure out what the coordinates are, and then we're going to use the distance formula to figure out the distance between those 2 points. So for our first point, we always use the one on the left. We need to start at the origin, right at the center, count to the left, 5 places. So if it's left, remember that means it's negative. So negative 5 would be the x coordinate. For the y coordinate, we go down 1 place, so that means negative 1. So our x1 would be negative 5, our y1 is negative 1. For our second point, we need to start at the origin again, count to the left 3 places, so that would give me a negative 3, and then we would count up 3 places, so that's positive 3. So my x2 is negative 3, my y2 is positive 3. Now I can use those coordinates and plug them into the distance formula. So we're going to have d equals the square root of, in parentheses, we're going to have x2 minus x1. So my x2 is negative 3 minus my x1 is negative 5, and we are raising that to the second power. Then we need our addition sign, again using our formula. y2 minus y1 in parentheses. So my y2 is 3 minus my y1 is negative 1, raising that to the second power. Remember, subtracting a negative is the same thing as adding a positive. So instead of minus negative 5, we're going to make this plus positive 5. And instead of minus negative 1, we will make this plus positive 1. So now we can go ahead and compute this. So we're going to have d equals the square root of negative 3 plus positive 5. The signs are different, so I need to subtract. 5 minus 3 is 2, and we are raising that to the second power. From there, we're going to bring down our addition sign. 3 plus positive 1, the signs are the same, so we add them. 3 plus 1 is 4. Still raising it to the second power. So we have d equals the square root of 2 squared is 4, just 2 times 2, so that's 4, plus, for 4 squared, we do 4 times 4, that's 16. After that, we need to add our two numbers together, so I have d equals the square root of 4 plus 16 is 20. Now, the square root of 20 does not come out nicely, all right, so you do need to use your calculator. If you have one of our calculators, the one that they use on the test, you will hit the second button, then the x to the second button, and then 20. You should get that d equals, when rounding to the nearest hundredth, 4.47. So our answer for problem number 4 is 4.47. At this time, go ahead and pause the video, try problems 5 and 6 on your own, find the distance between those 2 points, and then come back to the video, play the video, and I will go over how to get the answers for those 2 problems. For problem number 5, the first thing I did was find the coordinates for each one of the points that they have given us. So for point number 1, I went over to the left 3, then down 3. So my coordinates were -3, -3 for x1 and y1. For my second point, I went to the right 1, then down 2. So my coordinates were +1, -2. x2 was +1, y2 was -2. From there, I plugged it into the formula. So I did the square root, and then in parentheses, I have x1, which is, x2, which is 1, and I'm subtracting from that x1, which is -3, raising that to the second power. Then with my addition sign, I did y2, which is -1, minus y1, which is -3, raising that to the second power as well. I changed each of those to plus a positive. Remember, minus a negative becomes plus a positive, so that way I could work it out. So 1 plus +3 is 4, still raising it to the second power. Adding to that, -2 plus 3 is +1. The signs were different, so I subtracted them. Keep the sign of the bigger number. So I have a +1, still raised to the second power. So 4 to the second power means 4 times 4. That's where I got the 16. 1 to the second power means 1 times 1. That's how I got 1. Add those together, and we get 17. And then the square root of 17, you would want to use your calculator. You should get 4.12, rounding to the nearest hundredth. So the distance between the 2 points for problem number 5 is 4.12. For problem number 6, again, the first thing I did was find those coordinates. So I started with the one on the left. That's my point number 1. I went left 5 places, so that's -5. I did not go up or down, so my y coordinate is 0. So x1 is -5, y1 is 0. For my second point, I went to the right 1 and then up 1. So both numbers were +1. So x2 is +1, y2 is +1. After that, I plugged my numbers into our formula. So I did x2 minus x1, so I did 1 minus -5, raising that to the second power, and then adding to that, y2 minus y1, so I did 1 minus 0, raising that to the second power as well. Now, 1 minus -5, I changed that to plus positive, so 1 plus +5, I went ahead and did the addition and subtraction. So 1 plus positive 5 gave me 6, still raising that to the second power. 1 minus 0 is just 1, raising that to the second power as well. So I did 6 to the second power. 6 times 6 is 36. So I have 36 plus 1 to the second power is just 1 times 1, so that stayed 1. Then I added them together. 36 plus 1 gives me 37. And then I took the square root of 37 using my calculator again, and you should get 6.08 when you round to the nearest hundredth. And that's the end of our lesson on how to find the distance between 2 points using the distance formula.